Hello, welcome. Thanks for joining this session. So tonight we're going to talk about generative AI, the learning path. So without further ado, let's get started. So here's the agenda. We will be talking about generative AI, just in general, like general introduction and talking about AI automation. I'll share some resources and the courses that you can take. And then we'll briefly talk about computer vision, the things you need to learn. And then we'll move on to NLP, large language model. We'll talk about AI applications such as RAG, and AI agents, and then we'll talk about MLOps. So first, I would like to talk about just generative AI and AI automation. I firmly believe that generative AI is something that everyone needs to know, right? And we're all users of Gen AI technologies nowadays. We use ChatGPT, Anthropics, or Google Bard. It has significantly improve our efficiency, right? Whether it's daily lives or using it for coding, data analysis at work. So I think most of us will be just be using generative AI, but we need to become better at it, right? Become more efficient and learn more about prompt engineering, to make ourselves a more efficient data scientist or machine learning engineer. And then we can use generative AI to help us with data annotation, labeling, and even using that directly for classification or different tasks. That allows us to free up the time and then focus on designing AI data science products powered by generative AI. So I think data scientists will need to sort of upskill themselves to adapt to generative AI. But there are people who will be building Gen AI solutions or applications, but that entails a lot of things. You can focus on fine-tuning large language models, even training large language models, even though I don't think there's a lot of room for everybody, because that requires a lot of money investment. So I think most of us will be working on fine-tuning large language models, and maybe in the near future, even this can be automated, sort of semi-automated, right? So I think the core competitive advantage of any company, leveraging generative AI is, first of all, they have proprietary data. So I think data is still the key, but then also fine-tuning, these models to their own data, and developing really interesting successful use cases. And that's probably the way to go. So, and I'm going to share some, details about how to get started tonight. But first of all, let's just try to understand what is generative AI. I might be oversimplifying this. But first of all, just like any machine learning system, right, it expects some sort of input and it gives you the output. But unlike the traditional machine learning, input could be, text, structured data, could be images. With generative AI, usually it starts with a prompt, right? That's why we're doing prompt engineering, but we don't really have to feed just text as prompt. It could be, multimodal, could be images as well. But in this case, it's text to image, right? My input is text prompt, and I'm expecting, an image as an output. It could be Midjourney, DALL-E, GPT-4, Vision. But we can feed images into large language models such as Falcon, right? Llama models, GPT models, and then we can ask the large language model to explain, the picture it's seeing. And then it will be able to, do the image to text generation. But there's text to text, image to image, different kinds of, generative AI applications. So what is large language model? Essentially, it's autoregressive, right? Next word or next token prediction, kind of predictive models. And some people believe that it's more complicated than that. It's more capable than just an autoregressive model. But I think most of the pre-trained models are following the autoregressive approach. But essentially what it means that, let's say, in the first step, right, your input prompt is my name is, and then you're expecting some sort of output. So let's say the model says that the output is most likely to be ChatGPT. So that will be the next token or next word prediction. And then you get a new sentence, right, which is my name is ChatGPT. And based on this context, it can predict the next word, right? And that the next word will become part of the context and use that to predict the next word. So that is autoregressive. What that means is essentially predicting the next word. But because we're able to train that on such massive amounts of data collected from the web, it actually sort of become a compression algorithm that compress the knowledge of the web, and that's why it's so effective at spitting out words and talk like a human, right? But it doesn't mean that the pre-trained large language model is very useful. And you still need to teach it, right? It has a lot of knowledge, but it can blabber, right? Things that doesn't make sense, a lot of hallucination problem. And that's why we need to fine tune these large language models. We need to do things like alignment. So there's a whole process or pipeline you need to follow. But the pre-training stage, it's very expensive, and it usually does something like autoregressive regression. Okay. So for those of you who just want to become like users of Gen AI technologies and become more efficient, right? For example, you're running your startup, your business or small business owner, you can't afford to hire a team of data scientists or business analysts, or you don't have a large operations team. AI automation, I think, is becoming very, very popular, and it's very, very important for many businesses. You can use tools like Power Automate, Zapier. There's similar, other similar tools out there, but these are automation tools that can help you integrate with thousands of applications. And OpenAI, Anthropic, Bard. These are just some of the agent tools or Gen AI tools that can be integrated with Zapier, and you can use that to, for example, automate your email response, automate your lead generation process. So a ton of applications. I think you guys must be aware of this already. There's also the no-code and low-code AI or machine learning tool. Essentially means that you don't really have to write Python code, right? If you have simple use cases, you don't need to do a lot of customization, or maybe you're not really specialized in machine learning and AI, but you still want to get something going, create something that's useful, prediction for your for the problem you have at hand. Then you can use no code and low code machine learning tools such as SageMaker, right? It has Canvas tool. H2O.ai has something called H2O Flow. There are also RapidMiner, Nime, different kind of low-code AI or machine learning tools. Definitely check them out if you don't really enjoy writing a lot of code. And these tools are becoming more and more, popular. So what are some of the generative AI and AI automation ideas? You can use that to, you can combine automation tool with, for example, ChatGPT, right? You can use that to automate transcription, translation, email automations, setting calendars and reminders. Lots of interesting use cases. You can even use it to connect to Google Sheet, databases, database systems as well. So I won't spend too much time on this. I think you're most likely very much aware about some of the cool applications. So how do we get started with generative AI, right? This is introductory level, just to help everyone to become more efficient. I think the first thing you need to learn is just prompt engineering or prompt design, right? You don't really have to use Python. You can just work with ChatGPT and some automation tool. So learn the basics of prompt engineering, prompt design. Try to use automation tool to help you become more productive. If you work in the data field, then try to become a more efficient data professional. We had an event last night. I think we did a we did some survey, like a Zoom poll. I think about 30% of the participants, that might be, 6 out of 15 participants who said that they already have been like using ChatGPT for data analysis actively. So that's a great tool, and it can help you. It doesn't really replace your job as a data scientist, but it can help you automate some of the tasks. Then why not? So definitely learn how that works. And then I think you need to learn more about data science and machine learning if you would like to become more technical. Learn, at the very least, learn, because working with ChatGPT, you ask one question at a time, and you can have multiple sessions, but it's not very scalable. If you have, let's say, a table of questions that has all the questions, or you have a folder that has thousands of documents you would like to process or extract entities, then you can use Python and OpenAI API, for example. You can use Python to interact with any large language model and use that for automation purpose. But if you would like to actually tailor a large language model for your own business use case, because you have your private data, then you'll most likely need to learn how to do fine tunings. That requires the basic understanding of machine learning, deep learning, and large language models, so that you can do fine tunings or even build RAG applications. Another approach to do this is just leverage OpenAI. I think GPT-3 and GPT-4 has fine tuning capabilities as well. You can just massage the data into the right format, and you can upload it to OpenAI for fine tuning. I don't know how scalable that is, but it must be very expensive if you have really large amounts of data. But still, the starting cost will be quite low compared to hiring a team of specialists. Okay, so this is how we get started with generative AI, but now let's try to get more specialized. So I'm going to move on to the next topic, which is computer vision. Oh, before that, just introducing some resources. WeCloudData has a generative AI introduction course. We're launching that in March. We also have a large language model specialization course if you want to become more technical. Some really good online resources I would like to recommend. deeplearning.ai has some introductory level large language model generative AI courses. Databricks has a large language model course as well. And definitely you can find resources on Coursera, Udemy. If you want to learn prompt engineering, AI Academy is one of them, but there are a lot of other similar institutions out there that they just sell 1 or 2 courses, and they do really well in that. There are also a ton of great YouTube resources as well. Okay. All right. Computer vision. Just a very quick introduction. Computer vision, when it comes to computer vision, I think most of us might just relate that to image classification, right? Now, in this particular case, let's say we have blueberry muffin images and we have Chihuahua images, right? We feed inputs into a deep neural network, right? And then we're expecting some sort of output. In this case, it's binary classification. We would like to predict if the image is a blueberry muffin image or Chihuahua. And then the model is going to give you some sort of probability, right? In this case, let's say when we feed a Chihuahua image into the model that has been trained, it will be able to generate prediction and tell you that 95% likelihood it's going to be a Chihuahua. That's the confidence level, right? But of course, if you want to work in computer vision, then you need to learn how to train the deep neural network. And when it comes to some of the modern computer vision algorithms, a lot of them are representation learning, right? Think of it as, if you have some machine learning background, then think of it as automatic feature engineering, right? People used to do handcraft and manual feature engineering in computer vision, but it doesn't work really, really well when you have a lot of images and different kinds of labels. So the accuracy performance is not going to be very good. So a more scalable way to do this, when you have millions of images, for training, you got to do this automatically. And there are different ways, and convolutional neural network is just one of those very effective way to do, representation learning. And then it can, create features and then use that to train another neural network for downstream tasks, such as classification. Okay, and these computer vision algorithms can be used for different purposes. Right? These models, whether it's pre-trained or transfer learning, you can use that for example, semantic search. Right? You can upload images and find similar images. We worked on a project in the past where the owner of the business, right? The business is basically furniture related. So they basically recommend furnitures for their customers, and then the customers will basically show them pictures of their current furnitures, and they say, "I'm moving to New York City next month. I'd like you to recommend some furnitures. By the time I move in, I want everything to be set up. I don't want to go to IKEA to buy everything," right? So there are like startups out there that provide this kind of services. So to help them to improve the efficiency, because the customers will be sending them all kinds of images, or sometimes it's a picture they see on Google, on Instagram, and then in their catalog, where they have like hundreds of thousands of images, they would like to do the matching. And this is semantic search, and of course you would like to do this in a more scalable way. But that's one of the computer vision tasks, right? We can use that for semantic segmentation, instance segmentation as well. A lot of good use cases. When you learn computer vision, one thing you'll have to learn is basically the neural architecture, right? Convolutional neural network, the CNN architecture, and its many different variations have been actively researched, and then you definitely need to know at least 5-6 of these architectures, understand the pros and cons. But when you're using them, right, these algorithms are usually open source, so you just leverage them to solve your problems. But you do need to understand how it works, and definitely need to learn how to stay up to date, right? So SOTA, state-of-art models or algorithms. I think you need to check out Paper with Code or Hugging Face, just to stay up to date on some of these latest technologies or latest algorithms that's coming out, and that will definitely help you if you would like to work in computer vision. All right, so how do we get started? First of all, if you would like to do computer vision, then you need to know how to build neural networks, right? That's the fundamental skills. Pick one tool. It could be PyTorch, it could be TensorFlow, doesn't matter. TensorFlow does very well in computer vision as well. And for you to access different kind of pre-trained models, use Hugging Face, right? Very popular for you to access different kinds of models. So you need to learn deep learning fundamentals, and then know how to process image, the basic image data processing, right? Processing, augmenting images using OpenCV, for example, Torch Vision. When you do machine learning, especially NLP tasks and computer vision, labeling data is often a challenge. So you need to know at least how data annotation works. And sometimes you may need to annotate the data yourself just to do some POC. There are a lot of online tools that you can use. They're like open source ones such as CVAT. But do some research. You need to find a data annotation tool and learn how that works. So you need to know how to prepare data, just like the way we do traditional machine learning. You need to do a lot of data pre-processing, data visualization. And then we move on to the algorithm. Now, in this case, it's more about like choosing the right architecture, right? And then a lot of parameter tunings, or applying pre-trained models for transfer learning as well. So one of the key concepts you need to learn is convolutional neural networks, right? That's just like the transformers models, that's really influential for the modern large language models. CNN models have been, at the core of modern computer vision as well. There are new, better algorithms out there. There are large language model based ones, but CNN is still most widely adopted approach. And on top of it, need to learn different types of, architecture, such as, ResNet, right? Definitely read some recent publications in computer vision. Graph neural network is something really nice to know as well, and it has different use cases. When it comes to practical applications and the use cases, when you apply computer vision, you're definitely using it to solve some, prediction tasks. It could be classification, it could be object detection, and semantic segmentation as well. And since we're talking about generative AI, you will definitely need to learn the generative models as well in computer vision, right? So GAN has been very popular, but there's also diffusion models, right? Stable diffusion, CLIP, and they're multimodal, models as well, and also the vision transformers. So it seems like there's a lot you need to learn, but hopefully this is the right sequence for you to follow, and definitely don't skip the data processing part, in this case, image processing. So that's computer vision. There's some resources. WeCloudData has a computer vision specialization course. It's also part of the machine learning and AI engineering bootcamp. But some other really great resources I would like to recommend. Stanford has the CS131 and also 231. These are computer vision courses. Definitely check it out. It's open source, I guess, so you can have access to slides. Most of those lecture videos are available on YouTube as well. MIT also has a really great course on deep learning for AI and computer vision. I'm sure you'll find some other resources on Coursera and Udemy as well. Now let's talk about large language model. So again, I would like to use the traditional ML as like, a comparison, right? And don't get me wrong, since we're talking about Gen AI today, but the traditional ML, it's still very valuable and very important. And I don't think you can use Gen AI to solve some of the most common use cases in the industry right now, because it's simply too expensive and it might be too slow and it's not very scalable. Okay, so most of the machine learning problems in practice, you got to use traditional machine learning method. But let's compare that, that to the traditional approach, right? Again, so machine learning systems expect input and generates output as well. But it requires usually a lot of labeled data for training, right? Because it could be like supervised learning and the data sets need to be labeled. And then the algorithm will learn from these labeled data, right? How do we label data? There are different tools and, also services out there, such as Labelbox. And you can leverage Mechanical Turks as well. Amazon SageMaker has a labeling service, which is called Mechanical Turks. But imagine you have millions of images, right? That just becomes like too expensive. I think some of the computer vision breakthrough actually came through this, because of this ImageNet data set that's almost like 10 million images, I believe. And these are like labeled, very high quality labeled image data. Even though later on people found a lot of issues with it, but at that time, that is definitely the golden data set for people to finally, because neural network has been around for many years and people just never had such a massive data set, right? Thousands of labels. And then finally, when they apply convolutional neural network or, computer vision deep learning models on these images, on this data set, they had a breakthrough. However, the challenge here is data annotation, right? Because they spent millions of dollars in 3 years on label 10 million images using Mechanical Turks. It's not feasible for many companies, right? So how can we possibly label so much data? Well, maybe we don't, right? So there's an approach called self-supervised learning, where you actually, don't need to label all of your data. And it's more popular in natural language processing, large language modeling, but I start seeing people adopting that for computer vision as well. Okay, so self-supervised learning. we talked about it. Essentially, it's just the next word prediction. I think I oversimplify this, but as long as you get the basic idea, right? Because ChatGPT is basically, predicting the next word, right? And that's why sometimes you can't really control the number of tokens or words in the output, right? You'll need to let it finish, right? So because it's just predicting one word at a time, and the second word you predict depends on the first word you predict, right? If the first word is changed, then the next word might actually change as well. But when we get a text blob, it's very easy for us to construct a data set, right? That always look ahead and find the next word. And so we can actually construct massive, data set for training purpose, and it can get data from Wikipedia, and it can just create a data set that always has the next word, and you mask it, and you can use that to generate a training set. Now, the challenging part is the cost. How to do this efficiently at scale, right? If you're dealing with 10 terabyte of data, it's going to cost you, I don't know, tens of millions of dollars to do that, right? These are called foundational models or foundation models, right? I guess only the big companies like, Google, Microsoft, right, can build these foundation models. Quite expensive. But some of the famous ones, Llama model, open sourced at Meta. Google has Palm. UAETI has the Falcon model. I think the most recent one is Falcon A1, 180 billion. Anthropic, they have Claude, OpenAI, GPT-4, and they might be working on GPT-5. I think it's confirmed, right? So, but we don't know when it's going to be released. And there's also the image models, right? Stable Diffusion, Gemini, which is multimodal. DALL-E is, image to text or text to image. So these are foundational model, and based on these foundation model, we can create lots of, smaller models or fine-tuned models or student models. They're different approaches. Okay, and this is sort of like the timeline, but being very actively developed, right? All right, and it's all based on the one research paper by Google called "Attention is All You Need," so these are the very traditional NLP sequence model, right? Sequence to sequence models, and then Google just find a more efficient way to do this, and that allows you to these models to have longer memory, so you can feed more context into it. And that is something called attention mechanism. And if you would like to get into Gen AI and large language modeling, you seriously have to read this paper to understand how attention mechanism work and how transformer architecture works. But let's not forget about the data, right? Take a look at Llama 2's, training data. It's curated from many different places. Common Crawl is basically a snapshot of the entire web, right? I don't know what the sampling ratio is, but it's a pretty massive project, right? And the data set is really, really big. So they use the data scraped from the web, which is Common Crawl. There's also the C4 data set, which is actually created by Google. And there's GitHub, Wikipedia, as you can see. This is the sampling proportion, but looks like, almost 70% of the data comes from the web. There's data from, C4, GitHub. That's why I can do sort of answer coding questions. Wikipedia, lots of books, research paper, Stacks Exchange. So this is the training data. Now, as you can see, it's roughly maybe 5-6 terabyte in total, or maybe 10 terabyte, right? That's the large language model that's going to cost millions of dollars to train. But the internet is generating way more data on a daily basis, right? The data generated like every single hour is already way bigger than this data that's fed into the Llama model. So I don't think we even have the computing power right now to train the entire data set that's collected, from the web. It's simply not feasible. But if we're able to do that, then I guess ChatGPT is going to be way more intelligent, I guess. So again, Llama model was only trained on terabytes of data. But internet generates like millions of terabytes of data on a daily basis, but it's already so powerful, right? And when you learn large language model, you need to understand the life cycle, right? Because when people say instruction tuned, aligned models, or fine tuned models, or teacher student distilled models, you need to understand that this is different types of models, and large language model has like some sort of like simple like life cycle, right? It all starts from the pre-trained unaligned models, right? You start with a random model basically, but you need to feed lots of data, right? Using self-supervised learning to do the auto-regression model, and that creates a pre-trained foundation model. For example, GPT models, right? It's very powerful, but it sometimes just don't follow your instruction. That's why you need to do alignment and instruction tuning. To do the instruction fine-tuning or supervised fine-tuning, you have to feed, right, instruction and answer pair, right? You have to prepare the data in a way that when you ask a very specific question, you're hoping that it can learn from the correct answer or the desired answer you're expecting. Now you're teaching this foundational model, but first of all, you need to have a foundation model, right? And then you teach it how to behave, basically. It may actually, has a lot of hallucination problem. So after the alignment, it's going to get better, but it doesn't solve the hallucination problem, though, right? It still hallucinates a lot. But when you ask some very, let's say when your question has some sort of toxic, or like bad words, and sometimes it refuses to answer the question, and it'll tell you that I'm just, AI chatbot, I don't know the answer. Or they will tell you my knowledge is only up till, let's say, end of December 2022, and therefore I don't have an answer for you. So these are actually, instruction tuned models already. Okay, if you feed that into a foundational model, whatever question you ask, it will just keep answering the questions and just blabbering whatever it's, the next word it's supposed to predict based on the statistical prediction. Okay, so there's aligned models, and then after that we can do fine tuning, and there are different levels of fine tunings, right? We fine tune models. Let's say we take an aligned model, which already sort of know how to behave, and then we would like to fine tune that to our task specific problems, right? Let's say we would like it to sort of be able to have knowledge about the law domain, right? Legal domain, or more knowledge about sports. Well, if you look at the pre-train, the data set for large language model training, a lot of these are like GitHub, Wikipedia, books. Well, most likely it's going to get its sports knowledge from Common Crawl, right? From data collected from internet. But we have to analyze the data to know like what proportion of it is about sports, right? It's not going to have, so it's definitely unbalanced, right? Problem when it comes to some sports. So, and if you have very specific questions and you want it to have some domain knowledge, you better feed your domain data into it, right? That's the proprietary data you can feed into an aligned model, and then you do further fine tuning, right? And then you get a much smaller model, but that model can actually, have better knowledge about your specific domain. So most of the companies are doing, fine tuning at this level. There's also the model distillation, which means you're going to get a much smaller model, right? Because most of these models are pretty big and prediction speed is very slow. You might want to have a model that not only has like less parameters, but also a more condensed model that performs maybe at 85, 90% of the big model, right? But the model is much smaller. So it's actually more useful in production. So sometimes people call this teacher-student model, right? So the student model is going to learn from the prediction of the teacher model. Now, it's very expensive to train a teacher model, right? It may cost you tens of thousands of dollars, or even way more. But then this teacher model is going to always be able to generate the prediction for the next word, right? And you can train a much smaller model just to predict the prediction of the teacher model instead of learning from the raw input data. That is going to save you a lot of computing power, and you're not going to build a model that's more powerful than the original model. But at least, you're hoping that it can achieve 90% of it. So there's always a trade-off, right? So hopefully that explains, the different types of, LLMs throughout the life cycle, and some of the needs for model fine tuning. But when you decide when to adopt each approach, right, it really depends on the use case and how much budget you have and how much time you have. Some of the common questions might be, should I pre-train my own large language model? I guess most of the time you should just not even think about it unless your company really have a need. For example, Bloomberg, they I think had a pre-train a foundation model called I think it's called Bloomberg GPT or something. But it's pre-trained on data collected from finance domain, right? But that's because they have a lot of proprietary data in the last 30, 40 years. And then for most people, I guess we're just using an aligned model like ChatGPT, right? I think this is the most common approach. You're not going to build, you just buy, right? You're buying the services, the API to have access to the API. And of course, you have to pay, you get charged by the context window and by the tokens you feed into ChatGPT. So when you have more users, and of course your bill, every month, like your monthly bill will be very high, but it might be worth it. Like if so you have to do the calculation and see, if that makes sense. But I think for most of the companies, it probably makes sense, right? But some companies will definitely not adopt this approach because they don't want to build their core business, right, on some other companies and APIs, because OpenAI may actually go out of business, or they will say that we changed our models. Like you can never control that, right? So if your entire business is built on top of this, I think it's very risky, right? I think when ChatGPT came out, you start to see a lot of startups, right, coming out, and they're just building an application on top of the OpenAI API. I think a lot of those businesses has already gone out of business, right? It's hard to sort of generate real revenues on that. And also it's not really a competitive advantage because everybody can do that. Okay. Now, what is your advantage? I think, again, it comes back to data. You have your proprietary data, then you can use that to fine-tune large language models. Fine-tuning is not always going to work. Sometimes, when you fine-tune the models, you feed your data into an aligned models, right? You're trying to fine-tune it. And then the original aligned models, now you're going to break some rules and they start to become like less aligned models, and it starts to become toxic again. So because these models are basically just a bunch of weights, right? It's very hard to control. So but hopefully you have your proprietary data and you do fine-tuning and you figure out how to build a much better and useful tailored large language model for your own business. I think a lot of companies are doing experimentation on this, and then you can do the distilled models as well. It depends on the use cases. All right. So I'll skip some of these details because I think I talked about them already. Now, how do we get started with large language modeling? Again, first of all, you need to have Python knowledge. Right? You need to be pretty good at Python, basic data processing, and then you need to learn deep learning, PyTorch or TensorFlow, know how to work with Hugging Face, right? So these are just ML AI fundamentals. And then before you jump into large language model, I think natural language processing and text pre-processing is very important, right? So you need to know how to clean data, right? Text pre-processing, data annotation, and data scraping as well, right? A lot of times you may need to collect data and label the data as well, especially when you're building a new business, right? And then you need to learn, I think the basic NLP like, algorithms, right? Such as, embeddings, word embeddings, TF-IDF, but those are like the traditional NLP approach. But when you move on to the sequence models, you definitely learn the fundamentals, fundamental algorithms such as LSTM. It's a little bit outdated, but still very important, concept to understand. And that sort of helps you understand why attention mechanism and transformer is much better way, right? So learn attention mechanism, study transformers architecture, and then start to work with large language model. So you'll be working with APIs, right? From Hugging Face, from PyTorch, but now you just need to understand the different types of large language models, right? Because they serve different purposes. GPT models may not be useful for every use case, right? So you need to understand there are different types of LLMs, encoder-only models, such as, right, encoder-decoder models, right, such as T5, encoder-only, BERT is encoder-only, and then decoder-only. Most of the GPT models and Falcon models are decoder-only models. And decoder-only models are the most popular ones right now because, ChatGPT is basically decoder-only model, right? But if you ever want to do things like fine-tuning, then you need to understand data pre-processing, data augmentation as well, right? When it comes to fine-tuning, there are different approaches as well, right? Sometimes, like before you even start to fine-tune your own model, because it costs money and you have to use GPU clusters, at least start with like 1 or 2 GPUs, right? You can always do prompt engineering, but in this case, it's called in-context learning, right? You need to learn how the indexing approach work. And RAG is kind of related to this, right? And then, of course, you'll definitely need to learn PEFT, which is parameter efficient fine-tuning. There are different methodologies. So there are additive methods such as soft prompting, adapter models. There's also low-rank adapters such as LoRa, QLoRa. This is a little bit more like technical. These are all jargons. But after you learn large language model basics, when you move on to fine-tuning topics, I think these are the things you will come across, okay? Some of the resources, again, WeCloudData has a large language model course if you just want to learn LLMs, but it's part of the AI engineering bootcamp curriculum. Some really great resources to recommend. If you just want to learn the basics, right? Deeplearning.ai, I think it's owned by or co-founded by Andrew N. It has some NLP, I think, courses. It covers large language model, but I would say it's not a very difficult course, right? But I think it helps you understand the fundamentals. And then the better courses, right? If you would like to dive deeper, then definitely the master's level courses, right? Offered by Stanford. So CS 324, 224N. So they have some large language model and NLP courses provided, okay? All right, so now, when it comes to generative AI, of course, some people are more into like computer vision, some, folks are more into large language modeling, but ultimately, I think you need to build applications, right? So let's try to understand the application landscape. I wouldn't call myself expert in this, but I'm just sharing my, the things I learned about or I read about with everyone. First of all, before we talk about applications, we're going to touch briefly on like AI agents and RAG. These are AI-driven like applications, and these applications can potentially replace jobs. Like some people are scared about their jobs being replaced, but I think you need to understand that replacing jobs is very different from replacing tasks. I think generative AI large language model right now, or potentially it can become really, really good at replacing some of the tasks. And I think very soon, it will outperform human on some of those tasks, or maybe it has already, outperformed human on some, tasks, certain tasks. But it doesn't replace a job that easily. I think maybe some experts are predicting, 20-30% of your daily tasks to be replaced by AI. but that essentially means that you're still orchestrating all of these tasks, right? So a lot of the real life jobs, you have to follow like a workflow. Even just to do like student registration, there might be like 30 different steps, right? All the way from, from like, signing contract and having the first meeting. Like there's so many different steps, and think of each step as a task, right? And the workflow, right? The procedures are created by human based on experience. Now, for large language models to be doing that, it needs to sort of get a lot of training data. And I think training data on this is very hard to harvest, right? There's autonomous agent out there that can sort of do planning and reasoning, but it's not there yet. Like definitely not there yet. So I wouldn't be too worried about my jobs being replaced, but definitely leverage some of these tools to help you become more efficient at your tasks. Okay. So one of the things I would like to mention is just retriever augmented generation, and the short name is RAG, R-A-G. Right? You probably hear about this a lot. I think in the industry, right, companies are talking less about like just pre-training their LLMs because they know they don't have the expertise and it's going to cost them a lot of money. And most of these businesses want to become profitable. So I don't think they'll want to spend their R&D budget on pre-training their own models, right? A common use case is to fine-tune these models. But it may be a even more more useful way for them to approach this Gen AI problem is just to build knowledge base, right? Most of the company already have some sort of knowledge base, but it's probably scattered around their company's database systems, right? They're like a company may have like hundreds or even millions of documents collected over over many years. It's impossible for us to even find these, right? But if you have a way to feed all of these and index them in a knowledge base, and then you can actually leverage large language models to sort of do very efficient semantic search, right? And this is RAG. So it requires some basic, building blocks, right? You need to have a knowledge base, which means RAG can be used to help reduce the hallucination problem of large language models, because when you ask ChatGPT, I think the GPT 3.5, right? When you ask who won the 2022 soccer or World Cup, right? It doesn't know that because it only has knowledge until I think April 2021 or something, or maybe January 2022. So it doesn't have that knowledge, right? And when it doesn't have that knowledge, it either tell you that it doesn't know, or it starts to hallucinate, right? So the external knowledge base can be used in this case, right? If you can index, the most recent articles, whatever, into knowledge base, then it can become very powerful, right? But of course, you need to have a better way to retrieve the knowledge, right, from the knowledge base, because your knowledge base may have like millions of documents. So you need something called knowledge retriever, right? And after you retrieve the knowledge, you still want a large language model to sort of help you summarize and generate the answer, okay? So this is still very interactive experience, right? So let's say, you have a lot of documents, that's your company's knowledge, right? You index them in a knowledge base. So the knowledge base here can be a vector database that stores the embeddings, okay? So for those of you who would like to become ML engineers or data engineers, I think in the future, you definitely need to become knowledgeable about vector databases, right? So index these these documents and whatever images and audios and videos into the vector database, and it needs to store them in a very efficient way. So when you retrieve the knowledge, right, the nearest neighbor or approximate nearest neighbor search is very efficient, because what you would like to search, it's just like Google search. You're running your query, right? And you would like to retrieve the most relevant document, or you would like to just ChatGPT to give you the best answer. But imagine you have millions of documents. So how does it find the most relevant document? Assuming that ChatGPT doesn't have that knowledge yet, right? For example, the ChatGPT doesn't really know anything about your company unless you tell it, right? Because it's not pre-trained on your company's data. So that's why you need to know how to store and index, right, these documents efficiently, and also allow it to do nearest neighbor search very efficiently. And in this case, it's just approximate nearest neighbor search. If the two documents are close to each other, that means they're very similar, or they're identical, could be, right? And then that's what you would like to retrieve, okay? So you want the document to be very close to the questions or the queries in a very high dimensional space. And that is probably what you're searching for. But because you have millions of them, it may actually just return you the top 50 documents that are all very similar to the query, right? And now you still need to do the ranking to figure out the best one, okay? But again, you have to prepare these external data and feed them into the vector database, so you sort of have a knowledge base, and then somebody will start asking questions, right? Who won the World Cup 2022? And the knowledge retriever is, first of all, it needs to understand this question semantically. How does it do that? Well, it can talk to, for example, ChatGPT or OpenAI. It has the embedding model, right? It will sort of vectorize the questions, your queries, and returns the embedding. Okay, so again, that question got asked, sent to ChatGPT, sent to OpenAI, but it doesn't have to be OpenAI. It could be, the Cohere embedding, models. There are different, models that can use for embedding, and then it sends the vector. It's not the question, or it's not the original text anymore, right? It sends back the embeddings, and then you send it to the knowledge base or the vector database. You ask a question and say, well, find me the nearest neighbors or the most similar documents in my knowledge base, right? And then it's going to basically project your question, right, onto this multidimensional space and just find the nearest neighbors, okay? In this case, we found this, document which is really close, right? It says Argentina were crowned the champions in 2022 World Cup. I'm oversimplifying this, but let's say this is the best and the closest answer we can find. We send the embedding back, right? But when we send the embedding back, we want ChatGPT to be able to tell us the answer, right? Because we don't understand embeddings. We still need the output to be a summarized human language, right? So at this moment, the knowledge retriever is going to basically feed the retrieved document embedding along with the original question, because the question embedding is the context, right? Large language models still want to know what question you asked and what is the potential answers, right? And then it's going to reorganize it and send you back the answers. And you're leveraging ChatGPT basically to become the knowledge, the generator in this case, right? And then it gives you the summarized answer. So this is what I would call like a naive retriever augmented generation, because it's the approach here is too simple. It's not very sophisticated, right? When you just plug and play, it's not going to work very well. And you have to do a lot of tunings, and there are advanced methodologies that we need to follow in order to make build a really good one, right? But yeah, so this is basically RAG. And then, you can go more sophisticated and just re-rank, right? Do the re-ranking. But there's also things like, data cleaning and chunking, right? Chunking the documents, because, you can have very long documents. How do you chunk that in a way that your documents or most relevant document will be more likely to be, to be found in these queries? And that takes a lot of knowledge and experience as well. But it's beyond the scope of this talk, but I just would like to give you, a little bit flavor about how RAG works, okay? All right, so RAG is related to like the indexing approach, right? But it's very much like, just building applications. You need database, right? And you need some sort of like, chat UI, right? And it's kind of similar to Google search. So you're actually building AI applications, and some people can call this like agent as well. But now let's actually talk about AI agents. And when I talk about autonomous agent, what I'm referring to is LLM-powered agents, right? Because there are many other types of like autonomous agents. People have been doing research for many, many years. But this is the timeline here. I don't know how many of these you're familiar with them, but I read about a lot of these in news. Worked with like, sadly, only one of them, the Auto GPT. But yeah, it starts from like Web GPT, right? It caught people's attention. And Auto GPT, there's Agent GPT, and now even like Hugging Face GPT, something like that. Yeah, there are a lot of agent tools out there, and definitely look into them if you are interested in building applications. Now, what I'm interested in sharing today is a picture I found on, I forgot the source, but it's a blog that I found that, you know, the author is talking about. I think it's a company. They're talking about building data LLM agent, but basically agent can help you automate tasks, but it's not just one task, because the agent will have the capability to do planning, right? So imagine you're working with multiple agents, but there's like an agent that serves as the brain, right? It can dispatch tasks to different other agents to do different things, right? So that's the autonomous agent, you know, stuff we would like to achieve. But I think we're in the early days of that, because, you know, there's a benchmark for text to SQL, which means you use prompt to generate SQL queries. When I looked at that benchmark, you know, I think most of the best performance is like 60%. It's definitely not going to replace data analyst job, but I think it's being actively researched as well. So it's quite interesting. But this could be one of the potential use cases, right? Imagine you're building an AI agent that performs some specific task, which is writing SQL queries to help you do data analysis, right? So at a high level, this is how it works. We'll just follow like the process here. So step number one, you need to feed or index, right, the metadata information from all of your data warehouse and databases and data lake, right? Because when you store tables and data in the database, it has metadata information, like things about the tables, table name, the number of columns, column names, the data types, which column is the primary index, right? And the missing values and row count. As all of these are metadata information that you can actually embed, right? You can use embedding algorithms and then embed them and store them in a vector database, basically. And this is the RAG approach, right? You can have a document retrievers, but you have to store these metadata, which is the knowledge about your data, enterprise data. You save them somewhere, right? And then when someone starts to ask a question, like a user, right? So step number 3 here is basically a prompt, ask question about the data, maybe, right? And then let's move on to step number 4. So this AI agent, right, is smart enough to know that, okay, if you ask me a question, now I need to do the document retrieval. So it's submitting the NLP query to the vector database. And instead of seeking for an answer, it's just looking for the right tables. Like, because when you say, tell me the sales of a certain product in the last week, right? Then the first thing it needs to know is that, okay, where do we read the data from? Which table should I be working with, or which tables I should be working with, right? So it's going to read into the vector database and retrieve the relevant tables in step 5. And now it's going to send the query, basically the user question and the tables, okay, to a large language model. And the large language model here is performing a very specific task, which is quite, you know, just question and answer, right? You're writing the SQL query. And agents get the results back, and it submits the query to the database, and the database executes the query and retrieves the results. The results could be a table, right? But you want it to even like be able to answer, like to sort of do some sort of analysis and summary, and then you can submit that query result to the LLM again, and it will summarize the response for you. So that's how a basic agent can work, right? But as you can see, this is an agent that helps you just do one thing. It might be able to do that really well in the future, but it's just like helping you to write, you ask one question, it gives you the response, right? But if you look at the whole like data analysis workflow, that really just help you answer one question. It's not going to help you understand everything. So you still need to know what question to answer. And then when you get the response, you need to be able to judge, is that a good response? Is that the response I need? Or is the response, like, does it even make sense? So if you don't understand the metrics and the data really well about the company performance, then you're easily fooled by the agent, right? Because the agent isn't, it's just trying its best, but it doesn't mean the answer is always going to be correct. So, but again, hopefully I help to understand like how agents work, in a nutshell. And if you would like to get started with Gen AI applications, and definitely learn how to work with RAG, that requires you to sort of know how to work with a bunch of tools. There's some agent tools, right? These are just frameworks such as LangChain, Llama Index, right? It's not an agent itself, but it allows you to build agent tools, right? So LangChain and Llama Index is really good on data processing side, but it can work as an agent as well. And you need to learn how to do data chunking. That's actually one of the key skills you need to have if you would like to work with RAG, because again, it's garbage in, garbage out. You need to figure out how to chunk the data in a way that you can do retrieval efficiently. Right? You need to index the data. Data cleaning is required as well. You need to pick one vector database that works best for your company, and some more advanced topics, query transformation, and even hybrid queries. Like, it doesn't always have to be a vector database. People have been doing sparse, sparse indexing for so many years, like such as Lucene-based Elasticsearch or Google Search. These are just a regular search engine database, right? It can still be very effective. It doesn't mean a vector database is always going to work better. And that's why people are sort of combining them. So you're making the same queries to two different databases, and you're going to get the results, re-rank them, right? So these are some of the advanced topics, but definitely you'll come across it when you start to work on building RAG applications. When it comes to agents, I think from my perspective, it's still too early. But you need to learn, like, maybe just get familiar with it, So follow some of the popular agent frameworks, LangChain or Microsoft AutoGen, who recently got released. I think these tools, like, it's very useful for building RAG applications, and some of these tools are RAG based as well. But if you want to build like serious agent tools, I think it's still too early. But definitely, follow the trend, right? When you want to maybe study agent architecture, just learn how other people do it. Like, for example, just read the papers, of these, or just go to the GitHub repo. Most of these has some sort of publication that you can read more about their approach, right? But when it comes to building an agent, you need to know how to do profiling, right? Agent need to be able to memorize things. And most importantly, it needs to be able to reason and do planning, and then take actions, which means it might be interacting with some other agents, right? So there's a lot to study here, but definitely follow the trend. I don't think there will be a ton of jobs out there that's building agents, but definitely there will be a lot more jobs building RAGs and fine-tuning large language models in the near future. All right, so that's AI agents and RAG resources. When it comes to the resources, deep learning AI has some LangChain and RAG topics. Those are really short courses, like 1 or 2 hours. So it doesn't go very deep. Very good as as starter, material. LangChain and Llama Index documentation is really good. I think it's pretty competitive. So they're always writing blog posts. I think reading some of those blog posts can be very helpful. It might be even better than taking some courses. And lastly, I would like to talk about MLOps, because when we're talking about like fine-tuning models and building applications, well, you need to have your large language models or machine learning models deployed in production so that you can use it, right? So here on this slide, I would like to explain the motivation for doing MLOps. So traditionally, this is how people perceive a machine learning system. They think that the machine learning code is the most important piece, right? But it turns out that an ML system is very complex, and when you look at the code base, the model training code is probably the smallest piece of code you're writing, right? It's very smart and intelligent, right? But to get something deployed in production and working properly, you need a lot more effort. It's cross-functional as well. So you need DevOps or MLOps experts who understand infrastructure. You need software engineers, or you need software engineering skills, right, to sort of package the model and deploy the model, build APIs. You need someone to build data pipelines and automate that, build feature store, and even monitoring the model performance in production, right? So for example, if your company's application depends on ChatGPT or OpenAI GPT-4, and then if they release a new model, and then that may actually impact your own application, because some of the prompts or prompt templates that you have developed or saved in the past, now you may need to change it because the same prompt may not give you the same answer anymore. So stability and reliability is one of the biggest challenges of large language models right now. Right? So how do you build a robust machine learning system, right? And it turns out that the MLOps world is a whole different world. It's very crowded, right? It could be very confusing as well. But that's why like ML engineering and MLOps engineering is becoming very popular in recent years, because companies see the needs of, going beyond just like building machine learning models to understand insight, using that for marketing campaigns. Company actually want to build applications, right? And now even large language model applications. But let's take a look at the traditional MLOps tech stack. There's the data engineering part, machine learning engineering part, software engineering, and also DevOps engineering. So on the data engineering side, I think data quality is important, right? Being able to scale your data pipelines, because sometimes you're building let's say if you're building like things related to online ad auctions, then you're dealing with like billions of records every day that you might need to use Apache Spark and Spark Streaming to process the large data. You can't really use Python and pandas. It's not that scalable, right? You may want to automate your data processing pipeline using dbt or Apache Airflow. So these are all data engineering stuff, and building the feature store, annotating and labeling data. It could be the data scientist doing these, but it could be the data engineering team doing that as well. When it comes to model engineering, we're talking about model packaging, right? Finding the best format to package the model so that it can be deployed in different environments. Model training and evaluation, of course, that's probably one of the most important piece, and choosing your algorithms, right? Doing training evaluation, that's many iterations to achieve the desired performance. You need to, along the way, you have to do a lot of experimentation, and you have to keep track of them. And that's why you need weights and biases. You need ML flow, and even SageMaker. Okay, and there's model tuning tools as well. When it comes to software engineering, right, after we've trained the models and packaged the model, now we would like to do model serving or inference. So that means you have to do software, development, right? Because you're building APIs. And do you go with a monolithic approach, or do you go with microservice approach? Well, you have to make a decision, and you have to sort of choose the right approach. Do you just need a serverless, architecture using Amazon Lambda, or do you need a dedicated Kubernetes cluster and then have kubeflow set up, or you just write your own Python code, like using Fast API maybe? So many different ways to do model serving. And when it comes to large language models, then we need to use different packages such as, Hugging Face TGI or VLLM, because the consideration for large language models is that the cost and speed is really important. If you just use the Hugging Face, right, inference, it's actually very slow. It's not that scalable. So you can't really use that in production. So you have to find a better way to deploy the model on the server and on the GPU servers, right? And if you're deploying the models on the edge, right, like medical devices or cameras, whatever, drones, then how do we fit the large language model onto a smaller device? So that's edge deployment, and it's also called tiny ML. That's an active research area, which I believe will become more and more popular as well. But these are things related to deployment and model serving. To build a robust machine learning system, we definitely need DevOps, right? But MLOps, DevOps, and sometimes they're used interchangeably, because here the DevOps will need to understand machine learning system. But that's basically machine learning system design, I guess. But you need to understand cloud infrastructure, right? Not just cloud infrastructure, but ML infrastructure as well. You need to understand GPUs, distributed training, distributed inference, right? And the basic CI/CD pipelines, automation, and monitoring is also very important, because you can have model drift, you can have data drift. So it's very complex, but that creates a lot of job opportunities. And as you can see, the model training part is just a small part of it. Okay, so there's a lot more you can learn in MLOps. But it got to be someone who's more interested in engineering and writing code. If you're interested more into like analysis and model training, then data science is probably a better way to go, path to go down. All right. But what about large language model operations, right? It's a little bit different from the traditional MLOps, because traditional models, deploying them, you just need like CPUs. You don't really need GPUs, right? And most of the models will have pretty low latency, and it's more scalable. Large language model, we know it's very expensive, and it's OpenAI charges you by tokens, right? So we need to understand compute hardware, right? You need to understand different types of GPU cards. Cloud, it's common. Like MLOps need to understand cloud platforms, but you need to, instead of just the traditional machine learning models, you need to understand large language models and also LLM infrastructure as well. So there are some new stuff you need to learn for sure, and the ecosystem looks slightly different, right? Here, if you're building RAG systems, then you need to know vector database, right? The way we manage and embed these data will be different. There'll be agent tools and frameworks such as LangChain, right? Yeah, and how to design prompts efficiently, right? If you're just working with ChatGPT, you can save all the prompts yourself, but what about the team? What if you want to share your prompt template with your team, right? How do you manage this efficiently? So there are tools out there as well, and experimentation, model training, inference. Inference is also a big topic for LLMs, because if you can deploy your models in a way that it can sort of generate predictions really, really fast, and also like cheap and low cost, then you will have your competitive advantage. Imagine two businesses both raised $10 million. Whoever who can build more efficient like model inference are probably going to save a lot. Like they're going to burn through the money, investor money, a lot slower. So, all right. So I think that's pretty much it. So the last slide, I just want to sort of explain how to get started with MLOps or large language modeling operations. You need to know a little bit about data engineering, data pipelines, orchestration, feature store, and governance. But again, it sounds very overwhelming. When you actually start to work in a team, in an MLOps job, I don't think you'll be like doing everything in one project, right? Sometimes you might get hired to sort of spend a couple of months to focus on the data engineering side of things. But in the next couple of months, you might be focusing on something else like building model inference and doing validation and monitoring. But overall, like these are ideally the things you'll need to learn, right? Yeah, so LLM engineering, it's like new title, I guess, ML engineers, LLM engineers. When it comes to LLM engineering, I think you need to understand distributed training. That's computation, distribution. As we know, pre-training large language model is very expensive. Even fine tunings, like when your data gets bigger, it's still like expensive. So you need to understand different levels of parallelism, right? There's data parallel, model parallel, and also pipeline parallel. You can learn these from Hugging Face documentation. There's parameter tuning, experimentation tracking as well, using, for example, weights and biases. Not that's like hard to learn. Model packaging, right? Using Onyx maybe. And then software engineering, like model inference, right? Model serving and testing. And when it comes to the ops side, then infrastructure, CI/CD, and also monitoring. So many things we need to learn. There's some resources as well. We cover most of these in the upgraded curriculum. So we recently upgraded our machine learning engineering bootcamp by introducing Gen AI, large language models, and also LLM operations. But there are also some other really great online resources, such as the CS 329 ML system design. And there's a blogger who has a website called Made with ML. It's a really good I think blog that or maybe it's a course that discuss a lot about like MLOps in production. Coursera also has a MLOps course. I think this is the one offered by Andrew as well. But hopefully these resources are useful. Yeah, that's my end of the presentation. If you have any questions, let me know. Feel free to send your questions to the chat. All right. What's the difference between RAG and knowledge-based embedding? RAG is like it's RAG has the indexing part, right? It has the retrieval part, it has the ranking, and also the answer generation. And the knowledge-based embedding is really just like embedding or indexing or saving, right, your company's whatever documents you have, like the knowledge base, in a vector database. So that's like that happens before someone makes a query, ask a question. You need to have these knowledge, right, turned into embeddings and stored in a vector database, so that when someone asks a question, you can retrieve those embeddings or the knowledge back. And the GPT models will understand these embeddings as long as you use the same algorithms, and then it will be able to tell you the answers. Which field out of all of the above will have maximum amount of entry-level jobs? So I think today we talked about a couple of things, right? AI automation or just Gen AI, computer vision, LLM, agents, MLOps. I don't think I'm experienced enough to sort of predict the future, but as far as I can tell, I mean, AI automation is going to generate a lot of job opportunities, because it's just have so much use cases. Every startup, family business, small business, and even large companies, they'll need AI automation, right? And then they do that in different ways, and they need to sort of reskill their employees to become more efficient with, prompt design, prompt engineering. It's the money worth investing, because your employees will be more efficient at work, and now they will have more impact, right? But it's not like very technical job though, right? Everyone can do that, but you do need to sort of equip yourself with this kind of skill set. AI automation does require like knowledge of working with different applications, but you don't need to be a developer to do that, right? Computer vision NLP definitely depends on the use cases. I would say there will be more NLP and LLM jobs out there than computer vision, right? But when it comes to computer vision, I think companies have very specific use cases. they definitely would prefer to hire specialists, right? So if you know all of these techniques, you will be able to find computer vision jobs. LLM field is going to be very competitive because of the hype, right? But it also has a lot of potential. AI agents, I think there will be a lot of job opportunities as well. If you come from developer background, software engineering background, right? I think this can be really good opportunity. Like you're building backend, like LLM driven like applications, right? Uh, so if you work as a software engineer, like you might be working with different stack, right? The MERN stack or whatever. You'll be working with like MongoDB, you'll be working with MySQL, PostgreSQL. But now if you're building like AI agents, you're working with vector database. It's just like a different API you need to work with. You do need to understand how RAG works, right? But I think that's something worth looking into for sure. MLOps, I think you won't find as many MLOps engineers as data scientists because data scientists can work, like in some of the banks we have trained in the past or worked with in the past, they can have like more than 50 data teams. Like these are siloed data teams embedded, integrated into different like business units. There's like marketing data teams, there's like, right? In the banks, there's sales, there's product, insurance, credit card. There are risk analysts, data analysts, business analysts, data scientists. But so there are a lot of these, but you don't need that many MLOps engineers and ML engineers to like build production system because it's usually just one team that's focusing on building production systems. And then they work closely with the product team as well as the IT teams and operations teams. But there's like way more competitions out there for data science. I think if you have the right MLOps engineering skills, you can easily stand out. That's it's yeah. That's just my take on this. Let me move on to some other questions. Yes, the recording of this will be uploaded to YouTube. So you can just go to youtube.com/@WeCloudData. Yeah, I'll tell you my name. You can find me on LinkedIn if you would like to stay in touch. And I work for WeCloudData. Is there any LLMs like AutoGPT which can perform web automation like Selenium? There are lots. If you look into like the GPTs, right? They have GPT store. It does some basic, automation already. So you can. Well, the easiest way is just to prompt ChatGPT and it gives you the code, and you still run the code yourself. But there are agents out there that can help you do web scraping. But I don't think you can find agents that can help you like scrape any web page. But if there are certain websites and web pages you would like to scrape, there are certainly agents out there that can help you do that. And if you look at like this SQL whatever example, right? Text to SQL example. Where is it? Yeah. So executing SQL, right, in database, that's like one tiny agent that can do that. But you just need an agent that can help you do scraping. There are lots of examples out there. Eugene had a question about the ML engineering bootcamp. Are there any recorded version of it? In a different time zone? Yes. We are launching self-paced bootcamps this year. We're rolling out this program by program. Our data engineering program is available. And then I think we're launching self-paced data science bootcamp in March, and ML engineer will follow that sometime this summer. But right now, if you would like to go through the self-paced bootcamp, the way it works is that you can start watching the live bootcamp recording, but of course the quality is not going to be as good as like Udemy. But we're recording these lectures. But what's different about the recorded bootcamp or self-paced bootcamp is that every week you have a ML engineer mentor that you can work with. So you get to talk to them once a week, but we also have office hours where you can actually talk to teaching assistants. It's more self-paced, right? So you can finish that in a month if you study like 20 hours a day, or you can finish that over the time of 6 months or 8 months. It's totally up to you. Yeah. But you'll have a mentor that you can talk to on a weekly basis, and then you'll have TA support. So it works for a lot of people. But if you prefer just to have live classes, right, to have live support and work on real client projects, then just join the live boot camps. For those career switchers that don't have real world experience in LLM, what's their prospects in finding LLM job in Canada? I think my answer to Ben is that, and Abby as well, is data science and BI or data engineering, it's already very competitive, right? It's a little bit hard to stand out if you don't have real experience. And that's why WeCloudData's data science bootcamp gives students like opportunities to work on real consulting projects. So that helps them fill the career gap, like the experience gap. But when it comes to large language modeling, like all of these companies, they either have not even started, they are like thinking about it, or they have started already and they're like just learning how to do it. So if you can build like LLM, deploy like a RAG, more sophisticated version of RAG, right, and have a blog post, you can easily stand out. Because when it comes to large language modeling, if you don't know, you don't know. And if you know it, you have like, it's like new technology that not many people know, right? Even the traditional data scientists wanted to upskill themselves. So that gives you the opportunity actually to save a couple of years. Like you don't have to go down the traditional like path to go through data science and machine learning engineering. Maybe you just get a ML engineer or LLM engineer job right away. Another way to get started is there might be prompt engineer jobs out there. Some machine learning teams out like in startup, they actually need a lot of prompt engineering. So maybe joining that team first and then seek for other opportunities. I know like I've interviewed instructors and teaching assistants who work in this field, and I realized that they did a lot of prompt engineering instead of like model fine tunings or so. Yeah, so there are definitely opportunities out there like this as well. Yeah, if you would like to know the cost of the program, you can go to WeCloudData.com and find our boot camps. The information should be on the website. Many people seem to enter these programs with masters. What are the future prospects for someone who only has a bachelor's? Yeah, so I think it's a misunderstanding that people think that maybe you see more master's people joining these programs or get jobs. But when you do, I think we did some data scraping like from different job website. I think when it comes to requirement, like 30% of those jobs, like 35% maybe of those jobs require like a master's degree. Like 30-40% of them, you just need to have a bachelor's degree. So yeah. So if you come from a bachelor's degree, of course, like compared to someone with master's, company may prefer them, like if you have the same skills. So all you can do is just like equip yourself with more skills and work on more projects. Trust me, like companies are always looking for someone who can do the job instead of someone who has a better degree. There are teams out there, they just believe in PhDs or advanced degrees. There's nothing wrong with that, but I've worked with a lot of hiring managers, like they don't really care. They just care like you can do the work and you can learn really, really fast and you can communicate well because they know when it comes to large language modeling, even the company itself is like learning all of these from scratch. They just need people who can learn and adapt really, really quickly. So the fundamental skills need to be strong though. Like you need to be really good at SQL and Python. It doesn't take a master's degree for you to get really good at Python programming. So in that sense, they don't have advantage, right? They may know, like, I don't know, like master's degree don't really teach you all of these, state of art stuff anyways. So I think you know, when it comes to MLOps, like there's no master's degree in MLOps yet, as far as I know. So if you know MLOps, then you can get MLOps jobs because it's still like scarce resource, like, you know, resource out there. Yeah. All right. I think that's it. Thank you very much for joining this session. And, you know, I look forward to seeing everyone in our future events. And have a good evening, everyone.